This will be for the con exercise, exponential versus linear growth. So just some notes before we begin. You're going to be given a table of x and y values. You want to look at the y values on the table. Okay, and if you are adding or subtracting the same number each time, the function's going to be linear. And if you are multiplying or dividing by the same number each time, the function's going to be exponential. Okay, if neither of the above work, then you select neither. So these will be the three choices in all of the problems. All right, so let's take a look at the examples. All right, so here we have the table with the x values in one row and the y values in another row. And they ask, is the relationship linear, exponential, or neither? Okay, so all the problems will have those A, B, and C choices. Now, all of these problems, you won't have to check the x values, okay? You can double check them if you want. But we can see in the x values, 16 minus 8 is 8. So to go from 8 to 16, we're just adding 8. All right, to go from 16 to 24, you're just adding 8. All right, so you really don't have to check the x values, but the y values you do. So let's see, how did we get from 2 to 12? Well, if we did 12 minus 2, that's just positive 10. So to go from 2 to 12, that's a positive 10. All right, and how about from 12 to 22? Well, if we did 22 minus 12, again, that's just positive 10. All right, really, you only have to do it twice to make sure. But if you want to see the third one, how do we go from 22 to 32? Again, that's just positive 10. Okay, we said in the notes, you look at the y values. If you're adding or subtracting the same number each time, that is linear. Okay, and the reason it's linear is because we did plus 10 each time. So that's why it's linear. It's plus 10 each time on the y values. Answer A, linear. All right, linear, exponential, or neither. Again, you don't have to check the x values. Okay, you can see they go up by 1 each time, but that will work on all of these problems. Anyhow, for the y values, how do we get from 1 to 3? Well, if you did 3 minus 1, that would be positive 2. How do we get from 3 to 9? Well, if you did 9 minus 3, that would be positive 6. Already you can see plus 2 plus 6, we're not adding the same number, so it is not linear. All right, now we're going to try exponential. Let me erase this here. All right, so now instead of subtracting, we're going to divide. So you just divide by the previous term. I'm going to do 3 divided by 1. And of course, that is just 3. All right, and now try it with the next two terms. 9 divided by 3. You're always dividing by the previous term. 9 divided by 3, that's 3. And one more time. 27 divided by 9. And of course, that's just 3. So, since when we divided, we got 3, that means each time we are doing times 3. All right, some of you can do this in your head. You can see that it's times 3. It's times 3. Okay, really, you only need to do it twice. I did it 3 times just to make sure. But if you do it twice and it works, that should be good enough. All right. So this one here is exponential. And that's because it's times 3 each time. All right, and that's for the y values. Exponential. All right, last one. As always, the x values, you can see they go up by +9. Don't worry about the x's. All right, for the y values, how do we get from 2 to 4? Well, 4 minus 2 is just +2. 12 minus 4 is +8. All right, already we can see it's not the same each time, so it's not linear. Let's try exponential. 4 divided by 2. 4 divided by 2, that's just 2. 12 divided by 4. 12 divided by 4, that's just 3. All right, so when we went from 2 to 4, we did times 2. When we went from 4 to 12, we did times 3. So are we multiplying by the same number? No. So it's not exponential, and in this case, it's neither. Okay, we can see already it didn't work. If you want to do the last one, how do you get from 12 to 48? Well, 48 divided by 12 is just 4. So the last one is times 4. All right, so clearly it's not the same, even for the multiplication, so it's not exponential, and it's going to be neither. Answer C.